All right, today's lesson is going to be solving problems by finding equivalent ratios. Now that we know what an equivalent ratio is, we're going to use it to solve some real-life problems. All right, let's start with example number 1. It's like a very long problem here. Okay, a county superintendent of highway is interested in the numbers of different types of vehicles that regularly travel within his county. In the month of August, a total of 192 registrations were purchased for passenger cars and pickup trucks at the local Department of Motor Vehicles, or the DMV. The DMV reported that in the month of August, for every 5 passenger cars registered, there were 7 pickup trucks registered. How many of each type of vehicle were registered in the county in the month of August? Well, before I start this problem, I think I would like to underline some important information because there's a lot in here. Okay, so I know the total registrations were 192, so I'm just gonna box it. I think it'll stand out more for me. So that was our total, and if we think of those tables that we've been making, that would be in my total side of my table. All right, so we had cars and trucks. Okay, let's see. For every 5 passenger cars, so we have 5 cars, I'm just going to call them cars, there were 7 trucks. So for every 5 cars, there are 7 trucks. So we have cars to trucks. So for every 5 cars, there are 7 trucks. We want to know, what it's asking us to find out is how many of each type of vehicle were registered in the county in the month of August. I could say 5 cars, but we know that there are a total of 192 vehicles. In our tables we made before, I'm going to draw a tiny little table here on my side. We have the number of cars, the number of trucks, and the total number. We added up cars and trucks and got our total. Now our total now is 12, and 12 is nowhere near what we need. So we need to figure out how to solve that problem. Okay, first we're going to come up with 4 different ratios that we can write. Well, we already wrote one, so we can do cars to trucks, and that would be 5 to 7. This is called a part-to-part ratio. That's a vocabulary word. I'd like for you to make sure that you mark that in your notebook or in your interactive student notebook. Part-to-part ratio. A part-to-part ratio is part of the whole, and we know the whole. In this case, our whole with this ratio is 12. So part of it is 5. To part of it, which is 7, is our part-to-part ratio. So kind of put that in your own words in your ISN. All right, that's one ratio we can do. Another ratio is we could flip them around and do trucks to cars. There are 7 trucks for every 5 cars. And again, because these are the parts that make up the whole, this is a part-to-part ratio. Okay, I still need 2 more. And this one is going to be a different kind. We could do cars, since we started with cars here. Let's start with cars. Let's go cars to all vehicles. Now in our little table we kind of created here, we have 5 cars, so we're going to start with 5 at the front of our ratio, and our whole total, all of the cars, is 12. So our 5 cars to all of the cars is another ratio that we haven't yet talked about. So this would be part, because cars is part of it. Part to, this is the whole thing. This is another vocabulary word that I would like for you to put in your ISN. Part to whole ratio. Part to whole is when you take part, again like our first part, to the whole part, to the whole thing. So we have part to the whole thing. So put that in your own words also and make it stand out so that you can find that vocabulary word later on. Okay, we need one more because we need 4 different ratios. We did cars to all of them. What if we did trucks to all of them? Trucks to all of them. Well, there are 7 trucks. Good thing I took notes on my problem there. And all of them, there are 12. Now, this is a little bit tricky because we know that all of them is 192. But in our ratio table, our total is 12. If you think back to the soccer problem we did a few days ago, we know that we had to keep going until we had enough. So we're going to kind of do that, but we're going to do a shortcut way to do that. Okay, this is still part to whole. Okay, so that kind of introduces us to 2 new vocabulary words here, part to part and part to whole. Okay, let's create a tape diagram. We can use some more practice with tape diagrams. Let's do a tape diagram to represent the situation that we have. We know that the ratio is still 5 to 7. So let's do cars, and I'm going to abbreviate. Well, no, I won't abbreviate on this one. I'll abbreviate on the next one. Cars, we have 5. So we're going to draw our tape to be 5 units long. 1, 2, 3, 4, 5. They're not quite even, but that's okay. It's a sketch. And then we have trucks. We're going to start at the same spot here. And trucks is more. Trucks is 7. So I'm going to go at least to here. This is 5, 6. I think 7 might be right about here. Just guessing. I do need to make the 5 line up with the other 5 so that I don't get confused on how many there are. 1, 2, 3, 4, 5, 6, 7. Okay, I have a tape diagram now. I have 5 cars for every 7 trucks. All right, well, I need to know first how many total units are represented in our tape diagram. If I count all of my squares, I know that there are 12 units. I also know that from our little table here, which is just a side note. We weren't necessarily needing that, but it kind of helped us to see it. Okay, so there are 12 units in our tape diagram. How many total vehicles were registered in the month of August? For that information, we need to look back in our problem, and there says there was a total of 192. So, these boxes, all 12 of these boxes, represent the 192 vehicles that were registered. Now, to figure out how many vehicles were cars and how many were trucks, we need to know what each one of these units represents. You know, a couple of days ago we thought maybe it could be 2 meters or 3 inches, or it could represent a lot of different things to find those equivalent ratios. If we have 192 vehicles, each box represents 12 units. To find out how much we have for cars, we need to take 192 and divide it by these 12 boxes. We're going to take all those vehicles and we're going to put some here, some here, some here, some here, just like we learned to divide way back when. Okay, 19 I can see, 12 will go into 19, so 19 divided by 12 I believe is 1. And then we're left with 72. And 12 times 6 is 72. So it looks like each box is 16 vehicles. So here are 16 cars, here are 16 cars, here are 16, 16, 16, and so forth. Now, we can go back to what we did a couple days ago. Now that we know that there are 16 in each box, we can take 1, 2, 3, 4, 5 times 16 to figure out the cars. All right, so cars is 16 for each one of them. times 5. I'm going to write it vertically to help out my brain. 6 times 5 is 30. 5 times 1 is 5, plus 3 makes 80. So we know there are 80 cars. I'm going to circle that because that's part of my answer that I'm looking for. And trucks. Let's look for trucks. We're going to use the same method, the same idea. There are 16 in each box. If there are 16 in each box, we can take 16. I'm going to put trucks down here. 16 times, we know there are 7 boxes. So 16 times 7. And again, I'm going to do it vertically to help my brain out. 6 times 7 is 42. 7 times 1 is 7. 7 plus 4 is 11. So we have 112 trucks. 80 cars and 112 trucks. Now, this should give us a total of 192 vehicles. So let's double check. If we add them up, 112 plus 80, it should, I'm all over the place here, I'm sorry, it should give us 192 total vehicles. 2 plus 0 is 2, 8 plus 1 is 9, 1 plus nothing is 1. So we know we did the problem correctly. Wow, that's a lot of steps. Okay, let's try another problem. Let's try another one. It's very similar, but it has a different method for going about solving it. Okay. This problem says that the superintendent of highways, so it's still same guy, he is further interested in the numbers of commercial vehicles, those used for businesses and like the big truckers that drive across the highways, that frequently use the county's highways. He obtains information from the Department of Motor Vehicles for the month of September and finds that for every 14 non-commercial vehicles, that would be our cars and trucks that we drive, 14 non-commercials, there are 5 commercial vehicles. So I think we have our ratio. I'm going to make note. I believe our ratio is 14 to 5. Now this would be, I'm going to put an N for non-commercial and C for commercial. Non-commercial to commercial. If there were 108 more, that's important, 108 more non-commercial vehicles than commercial vehicles, how many of each type of vehicle frequently use the county's highways during the month of September? Wow, this one's a little bit trickier. Let's start by making a tape diagram, shall we? All right, let's do a non-commercial. I'm just going to put non. For non-commercial, we can abbreviate that one, it's kind of a long one. This one was 14. Ooh, it's going to be a long tape. We need 14. I might have to add a few here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think I made it. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Perfect. If you didn't have enough, just add on to the end. Okay, and we need commercial, and I'll kind of squish that in here. Abbreviate. I'm going to start at the same place. In the commercial, there were 5. 1, 2, 3, 4, 5. I'm going to match that up so that it looks the same proportions there, the same ratio that we need. All right. So we have our tape diagram. Let's see what we know, how we can solve this problem. We know that there are 108 more commercial vehicles. So whatever this number is, there are 108 more of these. So whatever this number is the same right here. Choose a different color. Whatever this number is, this right here is how much more? This is 108 more than whenever this stops. So this is 108. because that is 108, more than the commercial vehicles. Okay, now we're going to use the same method we did on the last problem. We know, let's just cover that up right here. We know that these boxes, we have 108 things we need to place evenly into each box. Well, if we count our boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, we know that there are 108 things that needed to be divided into 9 boxes. So I'm going to take 108, I'm going to divide it by 9 boxes, and I'm going to put an equal amount in each box. All right, I can see that I'm going to go over here into my 10. So 10 divided by 9 is 1. 18 divided by 9 I know is 2. So there are 12 vehicles in each box. Now, if each box is the same, that means each of these boxes is also going to be 12. We just used these because those are the ones that we knew how many it was. Okay, so if each of these is also 12, we're going to go back to that same method we used for the first example. There were 14 non-commercial vehicles, so I'm going to take 14 times 12, because there are 12 of them there, 12 in each, 12 times 14. 4 times 2 is 8, 2 times 2 is 1. I'm going to move over a placeholder, and you might put a 0, I put an X. It's just the way I learned it. 1 times 4 is 4. 1 times 1 is 1. Add those together, and I have 8 plus 0 is 8. 4 plus 1 is 5, and 1 plus nothing is 1. So we have 158 non-commercial vehicles. Did I do that right? Oh, time out. This is a 2. I didn't think that looked right. Okay, I multiplied wrong. 2 times 4 is 8. 2 times 1 is 2, not 1. Come on, Mrs. Jaworski, get it together. All right, so then 2 plus 4 is 6. I had worked that problem earlier and it just didn't sound right. Okay, if each of these boxes is 12, we know that each of these also has to be 12. There are 5 of them, so we can do 12 times 5. 2 times 5 is 10. 5 times 1 is 5, not 1. 5 times 1 is 5, plus 1 is 6. So there are 168 non-commercial vehicles. And there are 60 commercial vehicles. Now, we want to make sure that our answer is correct, so we can add them together. And no, we can subtract them this time. We don't know the total, but we know that for the non-commercial is 108 more. So if I subtract them, then I know that this one has to be 108 more. So my answer has to be 108. Perfect. So that I know my answer is then correct. Ooh, this was a lot of information. If you have any questions at all, please write them in your ISN and bring them to class tomorrow. We will definitely do more in class tomorrow.